Okay, let's take a look at the polynomial form. I call it ln times quad, meaning a linear factor multiplied by an irreducible quadratic factor. Anytime we use quad in this sort of notation, it means an irreducible quadratic factor. Okay, so the example I'll use here is y equals p of x is x plus 5 times x squared plus 4x plus 10. Now, zeros at x equals -5, get that very simply. And then we check out to make sure this polynomial, or this quadratic factor, that really doesn't have zeros. Okay, if you set this quadratic factor equal to 0, you get x equals -4 plus or minus the square root of 16 minus 40 over 2. We can see that this discriminant is going to come out negative, -24 if you want to be specific. So I'll say we have a negative discriminant. So it has no real zeros. It follows that this polynomial has a 0 at -5 and nowhere else. So we can sketch a graph. I don't really need a very big graph to indicate this. Okay, here's -5. Now we know that when x is a large negative number, that, well, this polynomial here is always going to be positive. It's positive if x equals 0. It doesn't have any zeros. This is always positive. So when x plus 5 is negative, this polynomial is negative. So we know that it's negative to the left of x equals -5, because for any number less than -5, x plus 5 is negative. So we have a negative times a positive. We can even indicate this. We have negative times positive, which is negative. On this side of x equals 5, on this side of x equals 5, we have positive times positive, which makes polynomial positive. And we know pretty well from what we've understood so far in the exercises we've done that x is going to become, as x becomes large, the value of this thing becomes huge, because it's going to act like x cubed. Okay? You get away from the x equals -5, get very far away from that, and the low point of this graph, which will occur at x equals -2, and the thing is just going to start approaching x cubed. So it's going to come up from below here, okay, and it's going to hit 0, and not necessarily approaching that correctly. Now there are little changes in slope and so forth that we can't analyze in this course. We'd analyze them with a little calculus, but we're not going to do that. So it comes up from below. I'll kind of skip here so I don't mess up my labeling of -5. Maybe it levels off a little bit, but then it just goes on up and gets up very steep and acts very much like an x cubed function. So that would be the graph of this function. Anytime you have a linear times an irreducible quadratic, you're going to have one 0. Determine whether it's positive or negative on each side of that 0, and you can pretty much draw the graph. Understand, it's going to have a graph that looks sort of like x cubed if you get far away from the zeros. Okay. Well, there's that case. And I could give you an arbitrary polynomial of this form. One other thing I'll say about this, of course, is that if we expand this, what do we get? We get x cubed, and then we're going to get a 4x squared here and a 5x squared here, so that's 9x squared. And we're going to get a 20x and a 10x, that's 30x plus 50. Now, if I gave you the polynomial in this form, you'd probably find it difficult to factor it and determine that, you know, these are the factors. You'd have no reason to even expect that you have a whole number factor here, that you have x plus a whole number here, and so forth. Okay? So we're not going to worry too much about factoring these things, although we will address it to some extent. So this is what the polynomial could look like, but this is the way it looks like when you factor it, and once you factored it, you can analyze the shape of its graph, at least make a good approximation to the shape of its graph. Okay.